Okay, today we're going to talk about circumference and the area of a circle. Okay? I bet a lot of you already know the formula for these. Okay? So, who remembers, first of all, before we talk about the formula, what is a circumference, by the way, of a circle? Okay, how about, this is all from intro, right? You don't? Okay, who remembers what a circumference of a circle is before we actually talk about the formula? How about Jonathan? Do you remember what a circumference of a circle was?
Outside of the circle.
Yes. What about outside a circle? What color it is, or
Measure.
what kind of measure? The distance, right, around the circle, right? It's kind of like the what? Perimeter of a
Circle. Square.
yeah, or yeah, perimeter of a polygon, kind of. So we don't have perimeter of a circle because perimeter is made up of a bunch of sides, right? Well, circles don't have any sides, so we need a different name for it. It's called circumference. All right. So who remembers the formula for circumference of a circle with radius r? How about Nicole? Do you remember? No.
Oh, pi times r squared.
Yes, pi times r squared. Are you sure?
Yeah.
That's the area.
Just kidding.
So that's the area, and then the circumference is 2.
2 pi r.
Pi
Yeah, that's the circumference. Okay, so please write this down. If you forgot, here you go. The circumference is 2 pi r. Area is pi r squared. By the way, where do they get this? The middle one, c equals to the circumference again equals pi d. Where do they get that from? How about Samantha? Do you see how they got this?
The diameter
Yes.
is twice the radius.
Exactly. The diameter is twice the radius. So if you multiply 2 times r, don't you get diameter? So it's the same thing. So the first two represents the circumference of a circle. The last is the area of a circle. Okay, go ahead, write it down. Okay, I'll wait. So today we're going to think about how we get these formulas. Okay, we're not going to necessarily prove these today, but we're going to talk about or think about how we could get these formula. By the way, pi. What is that pi? That's represents some number, doesn't it? What number does that represent? How about Grace? Yeah, it's about 3.14, but it's not exactly 3.14, is it? You're right. It's a number between 3.14 and 3.15, if you want to think about it that way. But what kind of number is this pi that we're saying here? This is a number that, could you write this as a fraction? Okay, some of you say, raise your hand if you think that, yes, this pi, that's about 3.14, you could write it as a fraction, about 22 over 7, right? And people say, no, you cannot write it as a fraction. You guys are correct, you cannot write this as a fraction. What is that 22 over 7? Because isn't that pi? No, it's what? It's an approximation. It's about 3.14 when you punch in the calculator. So sometimes, right, I remember from the intro, they ask you to plug in pi as 3.14. Some of the problems they ask you to plug in 22 over 7. By the way, when they ask you to plug in 22 over 7, can you plug in 3.14? No, don't do that. If they ask you to plug in 22 over 7, plug in 22 over 7. And the reason why they do that is because things will cancel out because it's a nice fraction. Anyway, so that's an approximation. So please don't think that pi is a number you could write as a fraction, okay? So what kind of number is pi if you cannot write as a fraction? Who remembers? It's called start with I. Michael? Irrational number is correct. So the number that you cannot write as a fraction are called irrational number. By the way, is pi the only irrational number you could have? Can somebody give me another irrational number? How about John? Rat 2, sure. Rat 3. What about rat 4? No, that's 2. Okay, so, but you're right. Okay, so please keep that in mind. So it's kind of good thing to talk about. So this pi, 3.14, we're going to show you where we get this number from, kind of. Okay. So here's what we're going to start with. Remember what we did last time? We talked about a bunch of these regular polygons, right? That are inscribed in a circle. Okay? And let's see how that has to do with figuring out the area and the circumference of the circle. It's showing why this is, why the formula comes out that way. So somebody read this for us. First consider. How about Dylan, can you read this for us? First consider. Mm-hmm. Okay, so stop right there. So notice we have a bunch of these regular polygons inscribed with a circle with radius r. Now look what happens as we increase the side. Now we have 4 sides. Next one you have 6 sides. The other one you got 8 sides, 10 sides. Imagine we kept on going, like 100 sides, 1,000, 10,000, million sides. What is this showing? What are they trying to show? Look at the regular n-gon. What is it looking more like? Iveta, what do you think? As we increase the number of sides, what is this n-gon looking more like? The circle, doesn't it? Right? Notice if you have 4 sides, it doesn't look very much like a circle, does it? But as you can see, as you increase the number of sides, right, isn't it becoming more and more like a circle?
Yes.
So it turns out if you were to increase number of sides by infinity, right, you would get a circle, really, right? If you think about it. So look what it says. As you can see, the more sides a regular polygon has, the closer it approximates to the circle. Does that make sense? Right? And why are we all of a sudden talking about these regular n-gon? Because what did we learn to do yesterday? Finding the area of the regular polygons, right? So let's do one for the simplest one. Okay, we could do the other one. But let's look at the simplest one, the 4-sided regular n-gon, which is a square. Can you all find me then the area of the square, okay, that's inscribed in a circle, and also the perimeter? Could you do that? No? Well, okay, very good question. Somebody said, wait a minute, don't we need some unit or some length or something? I'm going to tell you that just use r as a radius. In terms of r, tell me what you get for the area and the circumference. Does that make sense?
Yes.
Go ahead, everybody try. I'll wait. Go ahead, work as a group. I'll wait. Let's do this together. How do we then, what do we need to find, let's first find the perimeter. Okay, to find the perimeter, what is it that we need here first? How about, Pomon, what did your team come up with? Yeah, to find the perimeter, what do we need? Yeah, we need the apothem. Why, Pomon?
Because it makes a triangle.
Right, what kind of triangle would this make? This A, let's call it A.
45.
Yeah, 45, 45, 90. Can I just draw this right here? Like this? So this is A, this is R. Is that okay? It's 45, 45, 90. How do we know, guys? It's 45, 45, 90. This is a nice review, right, from yesterday. How about, how do we know this is 45, 45, 90? Amy, why is it 45, 45, 90? Right, so you could do 360 divided by 4, right? And so this, the whole thing is 90, right? Well, half of it's got to be 45, correct? But how do I know this right here is 45 also? Okay, I know that this is 45. Well, this is 90, so it's got to be 45, right? That's kind of obvious, sorry. So then, I answer my own question. Then, okay, that's great. What would I call this side then also? What should I call that? Kevin? Yeah, same as A, right? Why is this also A, class?
45, 45.
Yeah, it's 45, 45, 90. And now in that, what do we have in here? We have A? We have a square, don't we? Right, so the apothem is going to be half of this side. Does it work every time like this?
Yes.
No. No, it does not. Okay, it works for this square. If it's a square, yes, that's what I meant. But if that's what you meant, you're correct. But what if I have like 5-sided regular column and so forth? No, it doesn't work. Okay, so let's find A. That's easy. How do I find A? How about Eamon? How do I find A? Yeah? Yeah, because you know that A is equal to what? I mean, you know that R equals to? The radius is equal to this. R is equal to what? A times rad 2. You guys remember that ratio? Right? 45, 45, 90 is 1 to 1 to rad 2, right? So the radius is going to be 1 of the side times rad 2. Well, how do I find A? We'll divide both sides by rad 2. So A is equal to R over rad 2. And of course, you got to simplify this. When you simplify, multiply top and bottom by rad 2, don't you get rad 2, R times rad 2 over 2? So we got A. That's great. Okay, so we got A. Now, how do I get this? Let's call this side S. What's S equal to? Twice of A. So what's S then equal to? R rad 2. Isn't that right?
Yeah.
So how do you find the perimeter? Well, 4 times the side, which is 4R rad 2. How many people got 4R rad 2 as the perimeter? Easy enough? Okay, of course, if you know the side, of course, area is easy because it's side squared, so it's going to be R rad 2 squared. What would that give you guys?
R squared or 2R squared.
Yeah, 2R squared. Okay, how many people got A as 2R squared? Okay, any question? Does this make sense? So this is a nice review of what we learned last time, correct? So here's, they actually did this for us too. Look, let's go down here. You see how number of sides is 4? They got us the perimeter. And then the area. Area, 2R squared. That's what we got, right?
Yeah.
What did they get? 5.66 R.
Pi.
Pi? We didn't involve any pi in this square. We said the perimeter is 4R rad 2, right? But here they say that it's 5. Yeah, you just multiply 4 times rad 2, right? That's about 5.66. So they just gave us the approximation. Is that okay?
Yeah.
So they just did that. Now, we could do similar things for all the other ones, can we not?
Yeah.
But they did it for us. So if you have 6-sided regular angon, right? You get 6 times R for the perimeter, and then the area is 2.6 R squared. Isn't that nice?
Easier.
By the way, for all the other ones, how are you going to figure out the epithem and so forth? So these are you going to get 45, 45, 90, 30, 60, 90 triangles on these? So how do you think they did it? How about Naomi? What do you think? You're not sure? Okay, so like, you know how, look at these, like, look at these regular angons. Like for 4 side, we know that it's 45, 45, 90, right? When you divide this to 6-sided figure, it's kind of nice. You get 60, 60, 60, right? So you get 30, 60, 90. For 8-sided figure, you're not going to get nice angles like that, right? 30, 60, 90 or 45, 45, 90. How do you think they did it for 8 sides and 10 sides and so forth? Without using those special right triangle, guess what? They had to use what? Okay, everybody go ahead and think about it. I'll give you, what do you think they did? Naomi, what do you think? They had to use trigonometry. For 6-sided, it's actually pretty nice, right? You get 30, 60, 90. But all the other ones, they had to use trigonometry. And we could do this, okay? And you did that as your homework yesterday, right? You guys remember? So let's look at this table again. This table is kind of interesting. Let's see if you guys see some kind of pattern. So for 6-sided figure, we said it was this. For 8-sided figure, you get 6.12 R for the perimeter and 2.83 R squared for the area. They did this for 10-sided figure. Kind of nice, they did it for us. Perimeter 6.18 R, area 2.93 R. Look at, they did it for 20 side. You get 6.26 R, 3.09 R squared. For 30-sided, you get 6.27 R, and then for the area 3 and 1/2. For 100-sided figure, they got 6.28 R for the perimeter, and for the area, they got 3.14 R squared. By the way, as you increase number of sides, what are these polygons looking more and more like? The circle. So anybody see anything interesting about this table? Go ahead, everybody discuss with your team. What do you think? All right, what did your team come up with? How about Austin? Anything interesting about this table? Yeah, what did your team come up with?
We found out
Huh?
that 100-sided polygon area is
3.14 times R squared, right?
Yeah. So if the area is pi r squared, then how is the area 3.14? Because pi is 3.14.
Very good. So as you can see, Austin is correct. His group is correct. As you increase the number of sides, as you can see, you see how these are look at the approximation of the area. It's kind of like pi times R squared, isn't that right? Look at this. Where did they get 6.28 times R for the perimeter?
Times 2.
Yeah, 2 pi R. You see? 2 times 3.14. Isn't that 6.28 times R? As you can see, as you can imagine, if we were to increase number of sides more, yeah, it's going to get a lot closer to that exact value of that 3.14, right?
Yes.
So these are approximations. As you can see, these are so this table shows us, right, that the area of a circle then, right, is going to be pi times R squared, and then the perimeter of circumference of a circle will be 2 pi R.
Wait, but it doesn't make sense.
Why not?
How is the area of pi r squared?
What?
Why is the area of pi r?
Because what was the area of a circle?
Oh, wait.
Yeah, pi r squared. You see how it's very
polygon.
right. So, but we're using these regular polygons to actually get, and it helps us to see why we get that number pi 3.14, right? So on. Austin, why don't you read this for us? See if this makes sense, because this is sort of a summary of what we just talked about here. As the table suggests. How about? Hold on, sorry. Here you go. Go ahead.
As the table suggests, each
Mhm.
perimeters give us a sequence of numbers that get closer and closer to a limiting number.
In this case, this limiting number is what?
3.1.
The pi, right? 3.14. That goes on forever. Go ahead.
This limiting number is defined to be the perimeter, or circumference of the circle. The area of a circle is defined in a similar way. The areas of the inscribed regular polygons get closer and closer to a limiting number defined to be the area of the circle. The results in the table suggest that the circumference is the area of a circle with radius r are approximately 6.28 r and 3.14 r squared.
Yeah, so the limiting number in this case they're talking about that whole thing, right? Pi, 2 pi r square, 2 pi r, and then for the area is pi r squared, right? The whole thing. It's not going to be any bigger than this, would it? Or any smaller, right? It's going to towards that number, right? So it turns out the whole thing, as you were to increase the number of size, right? It will be, for the circumference of the circle will be 2 pi r, and then the area will be pi r squared. So this kind of table shows us where they, it kind of shows us the value of pi, sort of, okay? It kind of makes sense as you increase the number of size, right? These regular n-gons are looking more and more like the circle, right? It makes sense as to how the area and the circumference are this way. Okay? That's a good question. If you increase number of size, will this number 3.14r, would it be like would it be greater than 3.14? Would it be 3.15? Can it be?
Yeah.
Does that change, you think?
Yes.
As you increase number of size?
Yeah.
You will not. No, that's what he's saying. Look, you could keep increasing the number of size, it will be that number right here, that's multiplying r squared, right? It will be pi times r squared. And this number for the perimeter will be twice of pi times the r. It will not keep on increasing.
No, wouldn't it go like 3.1415?
Well, I mean, yeah, in terms of the decimal place and so forth, yeah. But what I'm saying is, this number will never be, like, you can increase the number of size to 1 million. This will not be more than 3.15. You know what I mean?
That's so weird.
That does not make sense.
But then,
It makes sense.
Why? Okay, so I want you to discuss. Okay, that's a good question. Why would it not? Why would it be a limiting number as they were talking about? Why would this number not increase as we increase the number of size in this manner? Go ahead, everybody discuss. Why wouldn't it increase? Go ahead. So that was a really good question. Take a look at this. Okay, who will actually want to explain to us as we increase the number of size? It looks like the number in front here, the coefficient, right, is increasing, doesn't it? Yes. But I'm telling you that this will not be bigger than the number pi, or this will not be never bigger than twice of pi. Why does that happen? How about? Okay, some of you. Okay, so that's a good question. It looks like it's increasing, but I'm telling you, it's not going to, and that's what this is saying here. Yechan, what did your group come up with?
I said, well, we didn't really get it.
Oh, one of your your group members willing to help. Okay, Josh.
That didn't make sense. You said the circle is practically an infinite amount of sides like a polygon. So then the circle will have the greatest area of all of them. And since the circle's thing is lower than 3.14, then it can't be.
Yeah, very good. Look at the pictures of here. Who wants to add something to that? Samantha?
So you know that the polygon is going to be inscribed or can be inscribed in a circle because it's a regular polygon.
Right.
So and you know that the area of the circle is pi r squared.
Right.
And so the more sides you get, you're going to have r squared, and it's going to be getting closer and closer to pi, but it can never go above pi because then it would be the area of the polygon would be greater than
Right,
the area
exactly.
of the circle.
You could increase the number of sides in this, right? No matter, very good. No matter how many sides you get inside, right? Would it be greater than the area of a circle?
Oh, no.
No, it could never be greater than the area of a circle because this is how right? These polygons, right? Regular n-gon is inscribed in a circle. It'll get closer and closer to the circle, right? But it can never be greater because if it did, then it's going to be greater than the area of a circle. Therefore, That's what they mean by the limiting number, right? This, right? As you increase the number of size of this polygon, right? It could never be greater than actual area of this circle. Does that make sense? So it's going to get more and closer to the pi, right? For the area times r squared. Does that make sense? So that's a really good question. Now let's do some examples. Turns out, actually, using these formulas and so forth is a lot simpler. Okay, so let's think about let's look at these examples. Okay, so let's do, by the way, somebody read this for us. This is important. Kristen, can you read this for us?
When you calculate the circumference and area of a circle, leave your answers in terms of pi unless you are told to replace pi by an approximation.
Good. So unless I say give me an approximation, guess what? You want to give me the exact answer. Is that okay? You're going to leave it in terms of pi. You understand? What if I ask for the approximation? Are you just going to give me the approximation, or are you going to give me the exact answer also? Yeah, I want both. I want the exact answer, then give me the approximation. Right? Okay? It's going to make it a lot easier, actually, if you do that. Do you understand? Just like how we did it before. So take a look at this example here. It says find the circumference and the area of a circle with radius 6 centimeters. Does it ask for the approximation? No. So what are you're going to give me the exact answer in terms of pi. Very good. Go ahead, everybody try. This is very straightforward. Okay. All right, so what's going to be the circumference for this? How about Esther? Over here, yeah. 12 pi. And what about your unit? Centimeters, right? Okay, so this is distance, right? So the answer will be 12 pi centimeter. Because you just plug into the formula. It's very simple. 2 pi r, okay, so you punch it in. What about for the area then? Did you all get 36 pi? Centimeter squared, you just square the radius times pi. Okay, very straightforward. Any question? All right, let's look at example 2 then. Okay, second. Okay, here we go. Find the circumference of a circle if the area is 25 pi. This time, they give you the area, they ask you to find the circumference. Okay, really easy. Yeah, these are pretty straightforward. By the way, does it ask for the approximation at all? No. Okay, go ahead, everybody try. Let's take a look at this here. Who can help us how to do this one? How about Esther over here? What do you think? What do we have to find first? Yeah. The radius. We need the radius, right? Because once you know the radius, you can figure out the circumference. So what's the radius, Esther? What did your team come up with? Sorry? 5 is correct. Did you all get 5? Yeah, you just plug into the formula again, solve for r. And of course, when you square root both sides, you get positive or negative 5, but of course, radius can't be negative, right? All right, then once you know the radius, did you all get twice of that times pi? So you get 10 pi as the circumference. Pretty straightforward? Easy enough? All right, okay, let's look at the last one now. Here we go. Okay, so let's look at the last example. It's pretty straightforward. This one also. Okay, this time though, it's a little bit different. Brandon, can you read this for us?
Photograph shows land that is supplied with water by the irrigation system. The system consists of moving arm that sprinkles water over the surface of the region. If the arm is 400 meters long, what is the area correct to the nearest boundary kilometers of the irrigation region?
There you go. So, yeah, you don't see the arm, but basically, what are they trying to have you figure out? The area of the green part. Yeah, no, not just the green part. The whole thing. Okay, so basically the area of this big circle. All right. Now this time though, they ask you to use pi, right? As 3.14. Now, do I want exact answer also? Yeah. Go ahead, everybody try. I'll wait.
So the radius is 1.
All right. So how do you find the area? How many people did this? Punch it into the. Use the formula. Pi times 430 squared, right? What they didn't give it to us, but what is 430 squared, by the way?
184,900.
Pi. That's the answer, okay? All right, so that's the answer, exact answer. Now, of course, you could use calculator for this. When you punch it in, 3.14 is this, you should have gotten 580,586. I'm done, right?
No.
Okay, why not? Why am I not done? Yeah, you should be unit squared. Hold on. Actually, the unit they give us, the unit is in? Not centimeters, meters. Okay. So, but we're not done. Why not? How about Andrew? Why aren't we done?
You need to put it to the nearest thousand.
That's right. We haven't rounded this. What would you get if you were to put the nearest thousands place?
581,000.
That's right. And of course, in meters squared, right? That's the unit. Okay, easy enough. Okay. Does this make sense? Yeah. Can you do something like this with your homework tonight? Yeah. Of course. Is your homework going to be this simple? No. It'll be a lot more interesting. Okay. Try it.